Hello class, we are going to consider another example, but this time we've been given the state diagram of our design and we are to design the counter. When you look on the state diagram, you realize that the count is irregular. 001, it moved to 010, 101, 111, and then 001. It is irregular. So that is the design given to us. Okay, so let us do the design. We want to see how the design will look like. They're given the state diagram. Okay, so because the state diagram is given, we are not going to repeat the state diagram again. So our first part in the designing procedure is catered for. The next thing we do is to determine the type of flip-flop we are going to use. So type of flip-flop. We were not told the type, so we will decide any type we want to use, be it T flip-flop or JK flip-flop. But I'm going to use JK flip-flop. So type of flip-flop, I'm going to use JK flip-flop. Then number of flip-flops that will be required. 1, 2, 3. Okay, so it's a 3-bit counter. So number of flip-flop will be equal to 3. So that is the first part of our solution. We determine the type of flip-flop and then the number of flip-flop. For this case, we are going to use JK flip-flop and the number of flip-flop we'll use equal to 3. Now, because we are going to use JK flip-flop, we come out with the JK flip-flop excitation table. Okay, so we come out with the excitation table for a JK flip-flop. So we have the present state, the next present state, we have the J input, and then we have the K input. Okay, so 0, 0, 1, 1, 0, 1, 0, 1. When the present state is 0 and the J there space there, we know for JK is 0, don't care. Okay, this we know already. So then we have don't care 1, and then we have don't care 0. Okay, so that we have. So this is our excitation table for JK flip-flop excitation table. So that is what we have. Okay, always try to name any table that you draw, name them. Okay, so from the excitation table, we are now going to come out with our circuit excitation table. So let us do our circuit excitation table. So I have Q, the present state. I'm doing the present state. QC. Okay, so this is my present state. Okay, then the next present state, that is going to be QC. I'll use plus, QB plus, QA plus. Then I have my input, so JC, KC, JB, KB, JA, and then finally I have KA. Okay, so this here become my inputs. Okay, my input of the flip-flop. Now, from the present state 001, we move to 010. From 010, we move to 1. The count goes to 101. From 101, the count is 111. And from 111, we go back to 001. Okay, so that is that. Now we determine our input, the flip-flop, by matching this to the excitation table. So let's do for the JC. So we pick QC, the present state QC, and the next present state QC. Okay, so 00 is 0, don't care. 01 is 1, don't care. Is 1, don't care. 11 is 0 or don't care 0. 11 is don't care 0. And then here too we have 10, which is 10, that will give us one don't care.
Don't care one.
It's don't care 1, right? So that we don't care 1. Okay, so that is for our KC. Okay, now let's do for JB. Let's do for our JB. Now in doing for our JB, we compare these two. Okay, so 01 is 1, don't care. 10 is don't care 1. 01 is 1, don't care. And then 11 is don't care 0. Right. Then we do for the C. So 10 is don't care 1. 01 is 1, don't care. 11 is don't care 0. And finally 11 is don't care 0. Okay, so that is what we have for our excitation table, and this becomes our circuit excitation table. Okay, circuit excitation table. We now do the K map, our Karnoff map. Okay, so we have 1, 2, 3, 4, 5, 6. So we do for 6. Okay, so let me do all. Good, so we are ready to go. Now here is my QC, QB, QA. 0001 11 10 01. So let's do for JC. So we have 001 001. JC is got what? 0, right? Then 010 is 1. 010 is 1. 101 is don't care. 101 is don't care. And then 111 is also don't care. So 111 is don't care. Okay, so there are gaps. We fill in with don't care. Let me use a different color. So this, the red ones, we are just filling the gaps with don't care. And remember, don't care simply means it could be either 0 or 1. Okay, good. So let's group. Now we have a gap here, so it means we can group this. Okay, so we'll get our JC is equal to, over here, this cancel this, then the common here is what? QB. So here, JC equal to QB. Right? So let's continue to find JC. So 00 01 11 10 01. Okay, so let's map. 001 KC is don't care. 001 KC is don't care. 010 KC is don't care. 010 don't care. 101 is KC equal to 0. 101 is 0. And then 111 is 1. 111 is 1. So again, I fill in the blanks. Okay, now here, no, this 0, so I'll group this 3 or this 4. Okay, once we do that, then we can get our KC, which equal to what? QB. So KC equal to what? QB. Okay, let's do for JB. So QC, QB, QA. Okay, so we are doing for JB. So 001 is 1. 001 is 1. 010 is don't care. 010 010 is don't care. 101 is 1. 101 is 1. And 111 is don't care. So 111 is don't care. So I can fill in these blanks, right? I'm using different colors just to differentiate from the citation table, and then the red is the blanks that we are filling. Okay, so here we can get all. So it means JB equal to 1. JB equal to 1. Let's do for KB. Let's do for KB. So KB, you have QC, QB, QA, 00, 01, 11, 10, and then 01. So we are doing for KB. KB. So 001 is don't care. 001 is don't care. 010 is 1. 010 is 1. 101 is don't care. 101 is don't care. And then 111 is 0. 111 is 0. Okay. 111 is 0. Are you sure our this thing correct? 111 is 0. Okay, so here is don't care. Okay, let me use the red pen. Don't care, don't care, don't care. Okay, so let's check our here carefully. When we're doing for KB, 10 is 10, okay, and 10 we know it should be don't care, not 0. So there's a problem here. Here should be don't care. Okay, so here should be don't care. Good. So always be careful, be careful, be careful, so that you not do mistake. Okay, be careful when you are checking the input using the excitation table. Okay, be very careful when you are doing it. So we have KB also equal to what? 1. KB equal to 1. Let's do for the last column, the last two columns, which is JA. So we have QC, QB, QA. So 0, 0, 0, 1, 1, 1, 1, 0. So we have 0 and then we have 1. Okay, so let's go. 0, 0, 1, JA is don't care. 0, 0, 1, JA is don't care. 0, 1, 0, JA is 1. 0, 1, 0, JA is 1. And then 1, 0, 1, JA is don't care. 1, 0, 1, don't care. And then 1, 1, 1, JA is also don't care. So 1, 1, 1, JA is don't care. Okay, so I can map everything. Okay, so giving me JA also equal to what? 1. Then finally, let's do for KA. So we have QC, QB, QA. So 0, 0, 0, 1, 1, 1, 1, 0, 0, and then 1. Okay, so 0, 0, 1 is what? 1 is 1. 0, 1, 0 is don't care. 0, 1, 0 is don't care. 1, 0, 1 is 0. 1, 0, 1 is 0. 1, 1, 1 is also 0. 1, 1, 1 is also 0. Wow. Okay, so let's fill in here. Because of these two zeros are mapped here. Okay, so when we group this, we have all the top will cancel. So we have KA equal to what? QC bar. QC bar. Okay, so we are done with our K map. We are done with our K maps to simplify our design. Now let us draw our circuit or do our design now. Let's do our design. So we have three flip-flops. 1, 2, 3. So this is flip-flop A, flip-flop B, and then flip-flop C. So this JA, KA, JB, KB, JC, KC, right? This becomes my QA, QB, QC. Okay, so it's a synchronous counter we are designing, so I need my clock, positive triggered clock, so which goes through all. Okay, very good. So this is my clock. That's my clock. Now JA is 1. Okay, so this is my JA. We are going to tie it permanently to 1. So JA is 1. So we've done JA. What about KA? KA is QC bar. So if this QC, this is QC bar. Okay, so this comes to JKA. So this is KA. So let me do this. So this is a simple design. Okay, so that is for the KA. Now we come to flip-flop B. JB is also equal to 1. So JB is also equal to 1. Okay, and then KB is also equal to 1. So it means I can tie KB and JB together. Okay, now I have JC equal to QB. This is my QB, this is my JC, so it goes directly to it. And then KC equal to also QB, so it means I can take it from here, and then they also come here. Okay, so now I'm left with my output. So this is my QA. So let me tap from here to be QB, and then finally this become my QC. Okay, so that is our design for the state diagram we were given. It's a simple design, as you can see, and so that is it. Take your time, go through, and we'll continue. Bye bye.